Hi, today we're looking at Functional Skills Maths Level 1. We've got the Training Qualifications UK exam board, and we're looking at the first of their sample assessment papers. We're going to start with the non-calculator section. Question 1. Work out -3 plus 5. Okay, well, good way to do this is to have a look at a number line. Let's draw this for us. So we're going to have -3 down here. We'll have 0 here. And we're going to plus 5 or add on 5. So if we think we're going to, let's put in -2, -1. So we're going to go plus 5, plus 1, plus 2, plus 3, plus 4, plus 5. Well, if we add the numbers in here, we'd have 1, we'd have 2. So our answer is 2. So in other words, it takes 3, we're adding on 3 to get it back to 0. And then we've got another 2 left in the positive area. Question 2. Work out 9 times 2.54. Okay, so I'm going to do this as a column multiplication. And I'm going to start off by ignoring the decimal point. So we'll say 9 times 4 or 4 times 9. So we've got 9, 18, 27, 36. Put the 6, carry the 3. Then we got 9 times 5, or again 5 times 9, because I like my 9 times table. So we've got 9, 18, 27, 36, 45. Add on the 3 makes it 48. And now 2 times 9 is 18, add the 4 is 22. But we don't stop here, because remember we did have the decimal point. So we had 2 decimal places here. So we're going to move the decimal point back in 1, 2. So we end up with 22.86. Question 3. Work out 20 plus 8 times 2. So we need our order of operations, which tells us that we need to do the multiplication first. Well, 2 times 8 is 16. So that means we've got 20 plus 16. Well, let's do this as a column. You might be able to do it without, but it's nice to show how we can get there. So 0 plus 6 is 6. 2 plus 1 is 3. So we've got 36. Question 4. Work out 65.83 times 100. So when we multiply by 10 or 100 or 1,000, the number of zeros is how many times we're going to move the decimal point. And it's time, so we're making the number bigger. So we're going to move the decimal point to the right, and we're going to move it 2 places to the right. So 1, 2. So in other words, we end up with 6, 5, 8, 3, or 6,583. And because the decimal point's now at the end, we can ignore it and leave it off. Question 5. Work out the range of these numbers. Well, to work out the range, we want the biggest number, so taking away the smallest number. So the difference between the biggest and smallest. Well, what's the biggest? Let's put commas in so it's easier to read these numbers. So we've got 18,000, 20,000, 16,000, 25,000 looks like our biggest. And this is in the 16,000s, so that's our smallest. So we want 25,050 minus 16,879. Okay, so we want to start with the units. So 0 minus 9. Well, we can't take 9 away from 0. So reduce that to 4 and make that 10. So 10 minus 9, we've got 1. 4 minus 7, again, we can't do it because 7's bigger than 4. So, and we can't take anything from the 0, so we have to move further along. We reduce the 5 to a 4, make that a 10. Now we can reduce that by 1 to 9 and pass 1 over. So now we've got 14 minus 7, which is 7. 9 minus 8, which is 1. 4 minus 6, again 6 is bigger than 4, so we need to reduce the 2 to a 1. Then we can make that 14 minus 6, which is 8. 1 minus 1, which is 0. We can leave that blank. So we end up with 8,171. Question 6. Leslie needs to cut a 56.2 centimetre long plank of wood into 5 pieces of equal length. How long should Leslie cut each piece? So we're splitting them up, or we're sharing it out, which means we're doing a division. So we want 56.2 divided by 5. So let's use the bus stop method. 5 on the outside of the bus stop, 56.2 on the inside. So firstly we say, how many times does 5 go into 5? Well, that's once. What about 5 into 6? Well, it goes once, but with 1 left over, so we put the 1 in front of the 2. We need to put our decimal point up here, so it's in line. So 5 into 12, well, you've got 5, 10 would be 2. But then we've got 2 left over. So what we need to do is put a 0 here, so we've got somewhere to put our 2. Okay, we've not changed the number by putting a 0 at the end because it's after the decimal point, so that's fine. But now what we can do is we can say, how many times does 5 go into 20? Well, you've got 5, 10, 15, 20. That's 4 times. So we've got an answer of 11.24. Right. Question 7. Let's move this up a bit. Work out the perimeter of this shape. Well, the perimeter is the distance round the shape. So pick a point to start. I'll pick there. So it's going to be 12 plus 2 plus 3 plus 4 plus 6 plus 4 plus 3, and then finally plus 2. So we're adding these all together. What you can do is maybe you want to do them in groups. Instead of just adding up down the column, you could say, well, 4 and 6, well, that makes 10. And then we've got 3 plus 3 is 6, plus another 4 is 10. So we've got another 10 here. And then we've got 2 plus 2 plus 2 is 6. So we've got 10, 20, 22, 24, 26. And then 1 plus the 2 is 3. Now, that might seem a little bit complicated, or more complicated than it needs to be. You can just start at the corner and add up as you're going. Or this one, which not everyone likes, is you can think of pulling your walls out. So you can think that this is actually going to have the same perimeter as having 12 at the top. If we pulled these sides out, we'd have 2 plus 4, so we'd have 6 down the side. We'd have the same on the other side, and we'd have 3, 6 and 3, 12 at the bottom. So you could then just work out the perimeter here. So you'd have 12 plus 12 is 24, plus 6 is 30, plus another 6 is 36, which is what we got. But this is just an alternative way of thinking about it. Question 8. A shirt normally costs £42. It is on sale with a 30% discount. Calculate the new cost of the shirt. Right, well, let's start off by working out 10%. Because 10%'s nice and straightforward to do. So 10% of £42. Well, you just move the decimal point 1. You're dividing by 10. So you end up with £4.2 or £4.20. If we want 30%, well, 30% 30%. Well, 30 is 3 lots of 10. So we're just going to do £4.20 times 3. And with this one, I'm going to keep the decimal point there. So I'll say 3 times 0 is 0. 3 times 2 is 6. 3 times 4 is 12. So the total amount of the discount is £12.60. So now we need to take that discount off the original price. So we've got £42 and we want to subtract £12.60. Well, let's give ourselves some zeros. So we've got something to take the 60 away from. Well, 0 minus 0 is 0. 0 minus 6 we can't do, so we again make that 1 and this 10. So 10 minus 6 is 4. Keep the decimal point. 1 minus 2 we can't do, so make that 3. And now we've got 11 minus 2, which is 9. 3 minus 1, which is 2. So we've got an answer of £29.40. Question 9. Alex has a part-time job. Alex receives £12.50 per hour and works 10 hours each week. Alex wants to pay 1/4 of the total amount received each week into a savings account. How much should Alex pay into the savings account each week? So we want to do £12.50 times 10 first of all to find out the total amount. So again, times 10, we're going to move the decimal point once to the right into there. So that's going to give us £125. Now we want 1/4 of it. So we want 125 divided by 4, which we'll do using the bus stop method again. 4 going into 125. 4 is into 1, or 4 can't go into 1 because 4 is bigger than 1. What about 4 into 12? We'll get 4, 8, 12. Yeah, so that goes 3 times. 4 goes into 5 once with 1 remainder. So again, we need to put we need the decimal point, and we can put a 0, so we can now put our remainder in front of it. We need to have the decimal point above as well. What about 4 into 10? We've got 4, 8, so that's twice, and 9, 10, so 2 remainder. So we need another 0 to put the 2 in front of. Basically, we put as many zeros after the decimal point as we need to keep putting our remainders in front of. 4 into 20, well, we got 4, 8, 12, 16, 20. So it goes exactly 5 times, so we can stop there. And we've got an answer of £31.25. And that's the end of the non-calculator section. So now we're on to the calculator section. Question 1. Calculate 48 squared. Well, that means 48 times 48. And the good thing to remember when you're doing these papers, once you get to the calculator section, you might be in the habit that you're working everything out manually, but you don't need to. We can just grab our calculator, 48 times 48, and you get 2,304. Question 2. How many pennies are there in £2.48? Well, there's 100p in a pound, or 100 pennies in a pound, so we're going to multiply it by 100, but I'm hoping that most people will be able to just think, well, that means I'm moving the decimal point twice, or you're just going to look at it and know, well, it's 248p, 248 pennies. Let's say if you're not 100% confident, you can do 2.48, multiply it by 100, and you still get the same answer. Question 3. Write this fraction, 5/8, as a decimal, and as a percentage. Okay, well, as a decimal, we can just use our calculator. So 5 over 8 means 5 divided by 8, which is 0.625. And as a percentage, well, if we want a percent, we just multiply by 100 to give us 62.5, and we can put the percent sign in there. Let's move this up here. In fact, we're going to need, there's a little probability line there. Let's see, we can't fit it all in. I'll have to move it up. These sweets are in a bag. 2 yellow sweets, 4 orange sweets, 9 red sweets. 1 sweet is chosen at random. What is the probability that a red sweet is chosen? Give your answer as a fraction and mark your probability on the scale below. Okay, well, if we're doing it as a fraction, first thing we're going to need is, well, how many have we got in total? So we can do 2 plus 4 plus 9 is 15. Okay, we can put that there. And we're interested in the probability that a red sweet is chosen. We've got 9 of those. So it's going to be 9 over 15. Okay. Or 9 out of 15, which 9 divided by 15 gives us 0.6. Right. Now, the reason I've worked out the 0.6 is because we've got this probability scale down here. And if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. So each of these is going to be a tenth or a 0.1, getting bigger. Which means if we keep numbering 0.4, 0.5, 0.6, so this is what we've got, 9/15, 0.6, so we can mark it with a big cross here. Okay, and don't forget to put our fraction in there. Now this fraction does simplify. If you put it as 3/5, that's fine, but they haven't said simplify, so either of these answers would give you the mark. Okay, question 5. The map shows the location of 3 UK cities. Charlie thinks Brighton and Sheffield are over 198 kilometres apart in a straight line on the map. And we're told that 1 centimetre represents 24 kilometres. Okay, and the question is Charlie correct? So what we can do with this one is we just need to measure that distance. So Brighton and Sheffield. So, I mean, Brighton's down here. Although it says Brighton to Sheffield, it's going to be the same as going from Sheffield to Brighton. So start here, and that comes out, I would say, exactly 8 centimetres. Now, if 1 centimetre represents 24 kilometres, well, 8 centimetres is going to be 8 times 24 kilometres. So 8 times 24 gives us 192. Charlie thinks the distance is over 198. Well, 192 is less than 198. So is Charlie correct? No, he's not. And we can write that down here. Question 6. Kai is playing a fairground game. The probability that Kai wins a teddy bear is 2/5. The probability that Kai wins a t-shirt is 3/8. Is Kai more likely to win a teddy bear or a t-shirt? Show how you decide. So they're saying which of these is bigger, basically. And because we can use our calculator, we can turn these into decimals, which I think will make them easier to compare. So we've got 0.4, which, if we multiply, might even find it easier to turn it into percentages. So 40%. So if we do the same with this, 3 divided by 8, and then multiply by 100, so that was 0.375, but by timesing it by 100, we get 37.5. You're probably fine comparing these, but this just makes it a little bit easier, and we can clearly see that this is bigger, so it's going to be more likely to win a teddy bear. And who doesn't like a teddy bear? Question 7. Which two of the following diagrams are an accurate representation of a net of this cuboid? So in other words, if you take this box and you flattened it out, think of it like as an Amazon delivery box or something like that, flatten it out, which of these 4 diagrams would give you that shape? Well, what we can do to start with is think about, we've got 4 different pictures here. Now you'll notice with some of them, we've got the big rectangle right next to each other, like these two. And others we haven't, we've got a piece in between. Well, if you think about this shape, you haven't got, this other rectangle is going to kind of be on the back here. But these two, they're not touching. You're going to have these smaller pieces in between them. So that means straight away we can say, well, it can't be B and it can't be D, because we can't have these 2 big bits touching each other. We're going to have, so I'll just draw that extra line in there, we're going to have a smaller piece in between. So that means it's either A or it's C. So you want to think about how you could fold these pieces up. Well, if we start with A, well, in fact, they've told us they want which 2 of the following are an accurate representation. Well, if we know it's not B and D, we don't even need to work out whether A and C are possible, because by a process of elimination, they must be. Okay, if you've got the time and you want to work it out, great. But as soon as we've ruled out B and D, we can say, well, it must be diagram A and diagram C. Question 8. Red gold is a mixture of copper and gold. The copper and gold are mixed in the ratio 1:3. Lee has plenty of gold, but only 600 grams of copper. Does Lee have enough copper to make 2 kilograms of red gold? Okay, so we've got a ratio question. Before I move on to the ratio bit though, I'm going to do some conversion, because we've got grams and kilograms. So I don't want to have 2 different units. I want to make them all the same. So I'm going to say, well, I know that there's 1,000 grams in 1 kilogram. So 2 kilograms is going to be 2,000 grams. Okay, now I've got everything in the same units. Right, now I can start looking at doing a ratio table. So we've got copper, we've got gold, and I'm going to have a total. So we've got 1:3 for copper to gold. So if that's all we had, we would have a total of 4. Right, now, he's only got 600 grams of copper. So we put the 600 in the copper column. And we need to say, well, we want to know how much red gold. So this total, actually, this is going to be our red gold. And we want to find out how much we can make with 600 grams of copper, so we can compare it to the 2,000 grams. Well, to get from here to here, because we're starting with 1, it's nice and straightforward. We're just multiplying that by 600. Okay. If we had different numbers, well, then we'd use our calculator to do 600 divided by 1. But we can see it's 600. So we're going to do the same with this figure here to find out how much red gold we can make. So 600 times 4, and we can make 2,400 grams of red gold. Well, 2,400 is more than 2,000. So does he have enough? Yes, he does. Question 49. Drew is asked for part payment of a bill. Drew is asked to pay £2,060 now. This will be 1/5 of the total amount that needs to be paid. How much will Drew need to pay in total? Okay, well, the first thing you're going to get a mark for is turning these words into numbers. So 2,060. Now, you might be tempted to write it like that, 2,060. Well, remember, we need hundreds. So we've got 0 hundreds. So £2,060. This will be 1/5 of the total. So what we're going to think, if this is only 1/5, the total is going to be bigger. And it's going to be 5 times bigger. Okay. So don't be tempted to divide it by 5. This is already a fifth. We've got to go the opposite direction. So 2,060 times 5 gives us £10,300, which we can write in here. Question 10. Morgan reads that an adult should drink 1.2 litres of water each day. Morgan drinks 8 cups of water each day. Each cup holds 160 millilitres of water. Does Morgan drink enough water? Well, this is similar to a previous, I think it was question 8, where we had different units. We've got millilitres and litres. I want to get them all in the same. So we're going to say, well, I know that there are 1,000 millilitres in 1 litre. So we're going to multiply this by 1,000. So 1.2 times 1,000 gives us 1,200 millilitres. Okay, now we've got something to compare to. Well, he's drinking 8 cups of 160 millilitres. So if we multiply those two together, we get 1,280 millilitres, which is more than 1,200 millilitres. So does he drink enough? Yes, he does. And again, we can put our answer down here. So, question 11. A company made 144, and if we count back 1, 2, 3, we can put a comma in here, £144,895 from selling mobile phones in 2020. The company set a target of increasing this by at least 40% for 2021. The table below shows the amount made in sales from January 2021 to August 2021. So in January to April, there was £59,618, and from May to August, £58,596. The manager says, if we make at least £84,500 more in sales, then we will have reached the target. Is the manager correct? Right, we've got quite a bit going on here. We've got to think about, well, what is our total target that we're aiming for to start with? And that target is going to be this, increased by 40%. Okay, so let's work out 40% of this to start with. So 40 out of 100 times 144,895. So this is how much it's increasing by. 40 divided by 100 times 144,895. So it's increasing by £57,958. So if it's increasing by that, well, then the new target is going to be 144,895, the original, plus 57,958. So if we add on the 144,895, we get a new total of 202,853. Okay. Now, they're talking about how much more they need to sell in the rest of the year. So in other words, from September to December. Okay. This figure here. Well, what we can do, if we combine these together and take them away from the total, that'll tell us how much more we need. So let's do 59,618 plus 58,596. We get a total of 118,214. So if we now take that off the total, so this is our 202, our new target, subtract the sales that they've already made. So 202,853 minus 118,214, and we get 84,639. That's how many or how much more they need in sales to get up to the target. He said if we make at least 84,500, we'll have reached the target. Well, 84,500 is less than 84,639. So is the manager correct? No, he's not. They need to make at least 84,639 to meet the target. Question 12. Last week it took Nikki 150 minutes to cook a chicken in the oven. Nikki has now bought an air fryer. The instructions say to reduce the cooking time by 20%. Nikki wants a chicken the same size as last week to be fully cooked by 1 p.m. Nikki starts cooking the chicken at 11:15 a.m. Will the chicken be fully cooked by 1 p.m? Show how you decide. Okay, right, so it's going to reduce the cooking time by 20%. So let's do 20% of 150. That's how much we can reduce the time by. So 20 divided by 100 times 150. So that's 30 minutes we can reduce it by. Well, if we have 150 minus 30, we're left with 120 minutes, which you might be able to spot. But if we want to turn it into hours, if we take off 60 minutes for an hour, we're left with another 60 minutes. So this is the same as 2 hours. So if Nikki starts cooking the chicken at 11:15, well, 11:15, if we add on another 2 hours, well, the minutes won't change. The hours will go up to 13:15, which, if you think in a 12-hour clock, well, 13 minus 12, well, that means that's going to be 1:15 p.m. So it's not going to be ready until 1:15. So will it be cooked by 1 p.m? No. Okay. Different ways you could work this one out, but I think that's a reasonably clear way, and we can write no down here. Okay. Question 13. A household keeps a record of how much they spent on gas from January to June. And we've got our figures here. Represent this data in a line graph below. Right, so we've got 6 months. So I'm thinking, maybe if we start here on the graph paper, would we have enough space? We could have January, February, March, April, May, June. Yeah, that works. Let's say we'll have Jan, Feb, March, April, May, June. And these are our months. Now we've got to do our scale going up. Well, what's the biggest value? 88. Yeah, 88 is the biggest. So we want to go up to at least 88 up here. So if we did 10, 20, 30, 40, we're going to run out. So maybe we say 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, so let's go up in tens for each of those sort of medium-sized boxes. Remember, we need to start at 0. Right, great, so let's draw this on. We always need to put our labels on the graphs. We put months down at the bottom. So here we can put, or we can call this gas spending, and it's in pounds. Okay, now we've just got to mark our points on the graph. So the first one we've got for January, we've got £86. Okay, here's January. Let's go up to here's 80. If we look between 80 and 90, this is worth 10. But we've only got 1, 2, 3, 4, 5 boxes. So if we do 10 divided by 5, that means that each of these is worth 2. So that would be 82, 84. So 86 is going to be there. Okay, you don't have to write it on. I'm just doing it to show you. So our first mark is going to go there for January. For February, this is February, we need £88. Well, if we know 86 is there, 88 is just going to be one box higher because each box is worth 2. Now for March, £71. March, let's read along. So 70 would be here. If this is worth 2, 71 is going to be just halfway up a box. April, we got £73. That's 70, that's 72. So 73, again, it's going to be halfway up. May, £65. So here's 60, 62, 64, halfway for 65. And in June, it's £61. So go up to 60, and 61 is half a box. Now to make it a line graph, we need to connect our points. And we work from left to right, joining them up. Doesn't matter if the line's going up or down, we just connect them one point at a time. And let's give it a title. We can just say gas spending. There we go. Question 14. Jessie wants to make 125 cuboid candles. The size of one candle is shown below. Okay, we've got our measurements on there. Jessie makes these candles from a block of wax which is in the shape of a cube. The cube has a side length of 80 centimetres. Jessie melts this block of wax to make candles. Is this block of wax big enough for Jessie to make 125 cuboid candles? So we're starting with a cube of wax with a side length 80 centimetres. So that's 80, that's 80, that's 80. But it's all melted. Okay, but what we can do is we can use this to work out the volume of the wax that we've got. And we can also work out the volume that we need for one candle and then see how many can we make out of the big cube. So the volume, well, of a cuboid, it's the length times the width times the height. Okay, when it's a cube, all of those are the same. So it's going to be 80 times 80 times 80. Or 80 cubed. So 80 times 80 times 80, which is 512,000, and that's going to be centimetres cubed. So now let's work out the volume of this cuboid. So the volume here is going to be 25 times 16 times 10. So it doesn't matter which order you're multiplying them in, as long as you multiply them all together. So 25 times 16 times 10, we get 4,000. So this is where you can do it in two ways. You can either multiply this by 125 to find out how much wax you would need, or what I'm going to do, which is slightly different, is take the 512,000, which is the total, oh, this is centimetres cubed as well. If I divide it by the 4,000, this will tell me how many candles I can make. So 512,000 divided by 4,000. And that tells me I can make 128 candles. Okay, so 128 is more than 125. So is a block of wax big enough? Yes, it is. They'll have some left over, or they can make some extra candles. And finally, question 15. Jamie is having their kitchen floor tiled. A planned view of Jamie's kitchen floor is shown below. Yeah, we've got some measurements on here. Each tile covers 1 square metre and can be cut to size once bought. Tiles are sold in packs of 4 and cost £38.70 per pack. How much will it cost Jamie to tile their kitchen floor? Show your working. Okay, right, so we want to work out the area first of all. Now, to do that, we want to split this into rectangles. So you could either split it down here, or I'm going to split it across this way. So the area of this big rectangle, well, area is length times width. Well, the length, all of this, well, actually, it's going to be this plus this. So we want 7.5 plus 2.5. Which is 10 metres. So we've got length of 10, width of 3. I don't need my calculator to tell me that that's 30 metres squared. Now for this little rectangle here, we've got our length is 2.5 metres. Our width, well, we haven't got this measurement here, easy to show it on this one. But we have got the full height is 3.4 metres and this bit is 3. So this gap is going to be 3.4 minus 3, which we can use a calculator for, is 0.4 of a metre. So this area is going to be 2.5 times 0.4, which is 1 metre squared. Okay, so the total area is 10 plus 1, which is 11 metres squared. Okay. Tiles are sold in packs of 4 and cost £38.70 per pack. Okay, so, oh no, sorry, got that wrong. Total area is not 10 plus 1, it's 30 plus 1, which is 31 metres squared. Well, that would give a very different answer. That's why we've got to be careful when we're doing these. Okay, so yeah, 10 was the length, 30, this is what we want to add to that one. So 31 metres squared. Okay, if tiles are sold in packs of 4, how many packs do we need? Well, we're going to need the 31 divided by 4. And that will give us 7.75 packs. But you can't buy 0.75 of a pack. So we need 8 packs. And if each pack is £38.70, the total price will be times £38.70. £38.70, which gives us 309.6. Because it's money, we have to make that 60. So £309.60. And that's the end of the paper. So I hope you found that helpful. Please like the video, subscribe to the channel, turn your notifications on to find out when I add more videos, and I look forward to seeing you again soon. Thank you.